Hello everyone, welcome to Stochastic Calculus for Finance 1, and this is section 6.23 on fixed income derivatives. And in this part, we're going to be talking about caps and floors. So first, our goals in these sections are, we're going to define this thing that's called couplets and floorlets. And these instruments are going to be actually building blocks for the next instrument that we're going to look at, which is caps and floors. And finally, we'll give an example on how to price these on the binomial interest rate trade that we have seen so far. Okay, let's now talk about couplets and floorlets. So if you let m be just some number between 1 and n, then what we're saying is m paired couplet is a contract that makes some payments, C, that we're not denoting Cm here, at a given time m. And this contract, this cash flow that is paying is basically given by this expression here, which is basically Rm minus 1, the interest rate prevailing at time m minus 1, minus some fixed amount k, right? And this is actually this expression is to say this is just the same thing as the maximum between 0 and this thing here. So that essentially this amount will be floor to 0. This is the payment. And on the other side, when we're talking about a floor, it's very similar to a couplet, but the payment that a couplet makes is given by this. So it's like a constant k minus the interest rate that will be prevailing at time m minus 1, floor to 0. This expression floor to 0. So now let's see how we can price this instrument. So a couplet is paying this amount at the given time m. So naturally, then the pricing, we're just taking the expected value under the risk neutral world, where we're taking this amount discounted at the time that we're receiving this cash flow. We're receiving this cash flow at time m, so it's going to multiply by dm. That is essentially what this expression is showing us here. This is just the risk neutral pricing formula for couplets. And for floorlet, naturally, it's the same thing. It's just the cash flow that you discount to the present. So let's let's talk about caps and floors. So very similar to couplets, but then the couplets, the cap is really like a contract that's going to make payments C1, C2, Cm. So it will have like many payments at time 1, 2, up to time m. And where like if we're given index or time period n, we're paying this amount here. And this is actually just the same as before. We can forget about the 0 here. The same thing for the floor. Same expression as well as the couplet. So really when you look closely, the cap seems to be really just a portfolio of some couplets, right? Of m couplets. And the floor seems to be a portfolio of m floorlets. So the horizontal pricing will be given by a very similar equation, but as then here now, because it's like just a portfolio, we're just taking the summation of these cash flows. So the sum of these couplets essentially, and the same thing for the floor. So we can actually from here note something kind of interesting, that if we're taking the so if you remember this, what this SN is, right, from the previous videos that we had on the swaps, this is essentially the payment, the cash flow that are happening on each time on a swap, right? So if we take the payment, this SN, the cash flow on the swap, plus the cash flows coming from the from a cap, then we'll find that that's actually exactly equal to this expression here. And so what that means is essentially if you have a swap for a given k, for a given rate k, the value of the swap for a rate k plus the value of the cap for same rate k is equal to the floor with that rate k. So you can think about it about some type of put call parity equivalence, but for swap, cap, and floors. So let's look at the example of pricing of a cup. So here we're considering a cup with a strike price of K equal to 1/3, right? And we like working inside the binomial interest rate tree that we had before, that we used to price the zero coupon bonds and swaps from up to now. And from this, we have seen before this table, right, that we use to be able to price zero coupon bonds on this tree, right? We have the different value for different states of the coin toss. And we know how to price a cap, right? So this is just basically the sum of cash flows coming from time 1 to m of dn, rn minus 1 minus k, and floor to 0, right? So naturally, if you're looking at the cap, at the cap 3, so as this we just replace the m in this expression here by 3, so we have this thing here. And if we pay close attention, the thing that we need to be able to find is like these discounting factors. We need to find these, and we already have that. We computed that before, so that's fine. Now we need to be able to know these r's, this r0 for each of the different states on these coin tosses. And we actually have that on the tree. We see here on the tree for each state that we are in, we know the interest rate, just as before. And then we need to be able to compute these values here. And this is essentially what we have down here. So when you have a look, we see R0. R0 is always equal to 0, no matter what the coin toss is. And that's because that's the initial value of the tree, right? At time 0, R0 is 0. So that's what we have here. And then we need to be able to compute then this expression here. And this expression here is just basically R0 is 0, 0 minus 1/3 plus, and naturally that's just basically what is the maximum between minus 1/3 and 0. That is naturally just 0. And we have that file here. Again, we have R1. And we know the value of R1 for each of these state of the tree. Then we can just put this value here. Then naturally we can just take this R1 and then minus just here 1/3 and see the value. If the value is less than 0, then we just replace it by 0 because it's floor at 0. If it's anything positive, then we just put that amount positive here. So just to have a look, for example, this 1/15, this one is coming from 2/5 minus 1/3. And then you do the math, you will find basically that you have this amount here. Okay. So that means that we can find essentially we can find these guys. This is checked. We can find these elements in between here. So then we just need to be able to now the last step is just to compute these expectations, and this table is going to help us with that. All right. So the first element here, the expected value of D1 times R0 minus expression inside this here is nothing but 0. Why? Because this expression here is 0 no matter what. So we just simplified that. Then we look at the second expression here. We need D2. So that is this row or this column that we're going to take and multiply by this column, which is the column that's like right next to it. All right. And then we need one expected value. So then naturally you're going to multiply also by the probability of being in that state. And that's what we have here essentially. So this first expression here, you wonder what this 1/15 is coming from. This 1/15 is coming from here, right? 5/7 is coming from the second element that we're multiplying it by, and the last element 1/4 is coming from the probability. And we do the same thing also for the second one. So we're just taking this guy multiplied by this guy multiplied by this guy, and that's essentially what you have here. And finally, the last part also, this 2/3 is coming from. So for the last part, we need a D3. So that means we need this column and this column, and then finally multiply by the probability. So 2/3 is this, 3/7 this, 1/3 this. And the other ones we are all zeros because the first expression here is just 0. So a fairly simple things so far. And then we can do the math and then find that we have the value of this cap is 5/42. So notice something interesting actually. So this expression here, we said the cap is essentially a portfolio of couplets, right? So this is really like the value of a couplet, of a 3-period couplet, right? So then that means at the same time we were able to price the 3-period couplets, and we find that the value of the 3-period couplets is just 2/21. Okay, so we can time to recap then for this video. So we just defined the couplets and flawless. We know now what these are. We know what these caps and flaws are, and then we showed also how to price some couplets and some caps on the binomial interest rate tree model that we have. All right, thank you for watching the videos and see you next time.